Well, over here we have what may seem to be a pretty formidable integral, which is x squared divided by the two factors of x squared plus a squared and x squared plus b squared from the limits of b to a, which we need to prove that all of this is equal to pi on 4 a minus b minus 1 upon a squared minus b squared times a times arctangent of b upon a plus b times arctangent of a upon b. Surprisingly, this integral is not as difficult as it may first seem. Let's try to break them into its partial fractions. Because these are two quadratic factors, we need to break it up into linear factors. Putting them all back together, equating coefficients. So on the left hand side we got no x squares, no x cubes, 1x squared, no x, no constants. So what we will have is, for the x squared terms we got ax times x squared, cx times x squared. For the x squared terms we got bx squared and we have dx squared. For the constant terms, we have capital B times little b squared, capital D times little a squared. And I forgot the linear terms, which will be capital AX times b squared, little b squared, which is and similarly cx times a squared is going to be ca squared. So equating, well, substituting some equations to each other, actually we have that this must be 0, this must be 1 because 1x squared on this side equals 1x squared on that side. This 2 must be 0 and this must be 0. Let's call this equation 1, equation 2, equation 3 and equation 4. Substituting equation 1 into equation 3, which was AC, let's put it into A plus C, let's put it into one of the A's or capital B's. Firstly, we should ensure that capital A and B and C and D stands for the coefficients of the partial fraction decomposition. Little a and little b are already constants of these two factors. Substituting this in, but we know that little b and little a cannot be 0 solely because this has happened. We know that little a and little b cannot be 0 then. In that case, capital A has to be 0. Let's substitute equation 2 into equation 4. But we know that little a and little b cannot be 0. So capital B could very well be a positive number. Could very well be a non-zero number. Capital C and capital D, on the other hand, since we know that capital A must be 0, and that from equation 1 over here, A plus C is equal to 0, C itself has to be 0. And because we know from equation 4 that A squared plus D, A squared times D, B squared times B is equal to 0, so that means D must be negative B squared on A squared minus B squared. Putting all of these constants back into the partial fraction decomposition. Actually integrating now. Pulling out the constants from both fractions. Actually integrating these things now. What is the integral of so what we have here is simplifying, we get if we were to put B and A into this X respectively, we're going to end up with A upon A at some stage, which is going to be arctangent of 1. And what is arctangent of 1? It's going to be pi on 4 radians. Simplifying even further by expanding all of this out. So these should not be squares anymore because on the earlier page these should cancel off. Combining these two terms, and putting the two arctangents together, because a squared minus b squared is just the difference in perfect squares, we can actually factor this guy out to become a plus b, a minus b. With that, we can actually cancel these guys off to become pi on 4 a minus b minus 1 on a squared minus b squared, a times arctangent b upon a plus b arctangent a upon b plus c. And there you have it.